Howdy, folks. We are going to learn the simplified way of making a linear programming model. So, Kroger supermarket sells its own brand, that is also called the private label, of canned peas as well as several national brands. As you might have witnessed this, the store makes a profit of $0.8 per can for its own peas and a profit of 0.19 for selling of national brands. So what does it shows? It shows the profit details are there. So there's a more chance that we will have to find the profit maximization. So you see the objective function of profit maximization is there. You see objective of profit maximization 0.28 uh, for the private label for its own brand Kroger and 0.19 for the national brand. The store has 6 square feet of shelf space available for canned peas. So the total store, this must be the constraint. Now we see the total uh, uh, space given to the shelf is for both peas. So the Kroger has to manage uh, within the space, and each can of peas takes up 9 square inches of that space. So we have also known that the every piece of uh, every can of peas would be taking the 9 square inches of that space. We have also known. So this is also we know. Now you see square inches and the space is given in 6 square feet. So feet and square inches. This is very important to understand that they both has to be in the same measurement scale. Okay, they cannot be in a different scale. So you see 6 square feet and 9 square inches. So square feet is the big one, so we change the square feet into the square inches, so it would be a lot easier to handle. So 6 square feet of shelf space available for canopy. That means in square inches, as we know, 144 square inches in a square foot. So 1 square foot equals to 144 square inches. So you see, we have changed the total shelf space available, that is 6 square foot into square inches. That is become 864. So 6 into 144 is 864. So you see the constraint equation has been made, in which the every kind of P, that is the local brand, X is the local brand, Y is the national brand. So every brand would take the 9 square inches space. You see, so 9x plus 9y equals to less than equals to 864. Why? Because it is the maximum space. That is why it is less than equals to. Let's move ahead. Now, point of sale records show that each point of sale is the record where the customer pays, okay, and get its product whatever he wants. So at the point of transaction, the records are being managed. The point of sale that records show that each week the store never sells more than half as many cans of its own brand as it does of the national brands. So what does it show? It shows that the sales of the shows that the its local brand, its own brand, its own brand sells not more than half of the national brands. So the equation would be like this: not more than, so it is less than and equals to It is never sells more than. So never sells means less than or more than half. So you see sales ratio constraint. It is called the sales ratio constraint. Okay. So this is like it. And non-negativity constraint must be you know X and Y cannot be private brand of peas and the national brand of peas must not be equals lesser than zero. It may be zero and more than that. So what we have to do, the store wants to know how many cans of its own brand of peas and how many cans of national brands to stock each week on the allocated shelf space to maximize profit. As we have already seen the maximum profit maximization equation, so we have to get to know the maximization of the profit equation. But in that we need to know the x and y. X and y can be known with the linear programming, any linear programming method. It can be graphical, it can be simplex, or any other software may be used. Thank you very much.